This adaptive brake topic block familiarizes you with the various braking functions. It deals with the following individual topics: overview of new features, normal braking, braking while cornering, stabilization of towing vehicle and trailer, brake drying, priming, air gap, as well as the adaptive brake light. The adaptive brake system combines the benefits of hydraulic braking systems with new electro-hydraulic functions. Quite apart from the familiar basic braking functions of ESP plus ABS, ASR, BAS, EBV and ETS, as well as speed-sensitive power steering, the adaptive brake system also embraces a host of helpful supplementary functions, driving assist systems and interfaces to other vehicle systems. Click on each of the terms for a summary of the new features. The priming function puts the braking system on standby whenever the accelerator pedal is released abruptly, thus shortening the brake response time. The air gap function is activated by high-speed cornering. The braking system goes on standby so that it can react more promptly should corrective interventions be required to stabilize the vehicle. The brake drying function sharpens the braking system's responsiveness when driving in the rain. The BAS Plus function uses the same sensors as Distronic Plus to detect obstructions on the road ahead. During vehicle braking, it increases the brake pressure in order to bring the vehicle to a stop without hitting an obstacle, if this is possible. This auxiliary ESP function is designed to stabilize car-trailer outfits by suppressing any snaking motion that may occur. Hill Start Assist prevents the vehicle from rolling backwards on an uphill incline while the driver switches from the brake pedal to the accelerator. The Hold function comes to the driver's aid when waiting in traffic, maneuvering and pulling away. The Tire Pressure Loss Warning System detects a pronounced loss in air pressure in any of the tires and flashes a warning message in the instrument cluster. If the vehicle is braked sharply, the adaptive brake lights flash to warn traffic behind. The adaptive brake system comes with a number of new braking functions. Match up the labels with the correct descriptions, then confirm by clicking on OK. Well done! You have correctly matched up all of the new braking functions with their descriptions. The adaptive brake system boasts a host of new auxiliary functions. Match up the functions with the correct descriptions, then confirm by clicking on OK. Well done! You have correctly matched up all of the auxiliary functions with their descriptions. Watch what happens during regular braking with the adaptive brake system. Click on the brake pedal in the schematic drawing. During braking, the driver transmits muscular energy to the brake pedal. The force acting at the brake pedal is relayed to the brake booster, where it is boosted in familiar fashion. Normally, when the brakes are applied, the speed at which the brake pedal is depressed remains below a certain threshold. Otherwise, the brake assist function would be triggered. The brake booster is followed by the tandem master brake cylinder with the brake fluid reservoir. The tandem master brake cylinder transmits the pedal force to the brake fluid in the two brake circuits. The brake pressure now reaches the adaptive brake system's hydraulic unit. During regular braking, the brake pressure is relayed to the wheel brakes unchanged. The brake pressure is finally built up at the wheel brakes. It is transmitted to the brake calipers, causing the brake pads to be pushed against the brake discs with the corresponding pressure. The next few pages take a closer look at each of the components featured here. The adaptive brake system uses a conventional brake booster. Click on the brake pedal to see how the brake booster basically works. When the brakes are applied, fresh air is fed via the fresh air valve to the rear face of the power diaphragm. The difference in pressure between the front and rear pressure chambers boosts the pedal force that is relayed to the tandem master brake cylinder. Move the mouse cursor over the diagram to display the names of the brake booster components again. In the case of the adaptive brake system, the brake pressure is built up in two brake circuits by the tandem master brake cylinder. The brake circuits have a black and white split. Move the mouse cursor over the cutaway diagram to display the names of the tandem master brake cylinder components again. The key component of the adaptive brake system is the hydraulic electronic control unit. This unit comprises the control unit and the hydraulic unit with high-pressure return flow pump. Let's start with a look at the hydraulic unit. It is broadly similar to the hydraulic unit fitted in braking systems featuring the electronic stability program, and contains pressure sensors and control valves. Click on the highlighted components in the diagram. A key feature of adaptive brake is its ability to monitor the individual brake pressures at the wheels by means of 4 additional pressure sensors. A 5th pressure sensor monitors the pressure reading at the tandem master brake cylinder. In order to allow the pressure in the wheel brake cylinders to be adjusted smoothly, the hydraulic unit uses continuously adjustable inlet and switchover valves. Instead of simple solenoid valves, which can only have 2 settings, open or closed, These valves act as pressure control valves which are able to finely modulate the discharge pressure. The 4 pressure sensors combined with the continuously adjustable valves to allow braking power to be regulated precisely at each individual wheel. The intake and outlet valves are solenoid valves which are closed when they are not energized. The high-power return flow pump is a component that is capable of instantly building up extra brake pressure if required. It comprises an electric motor and 2 pump elements, with the pump elements supplying pressure to 1 brake circuit each. The structure of the adaptive brake system is shown here once again. Click on the hydraulic unit to take a look inside. Click on the component labels to familiarize yourself with the structure. In addition to the basic braking functions already mentioned, such as the electronic stability program, anti-lock braking system, and acceleration slip control, the adaptive brake control unit also incorporates a host of helpful supplementary functions, driving assist systems, and interfaces to other vehicle systems. It processes the readings from the various sensors, receives the signals sent by the driving assist systems, and controls the hydraulic unit. You are familiar with the primary components which together make up the adaptive brake system. What type of braking system is it in your opinion? Click on the correct answer from those shown. The design of the adaptive brake system is largely the same as that of a conventional power-assisted braking system with electronic stability program. Which of the following braking systems includes a brake booster? Click on the correct answers, then confirm by clicking on OK. Excellent. The adaptive brake system is fitted with a brake booster, as are the more familiar hydraulic braking systems featuring ESP and ABS. Which of the valves in the adaptive brake hydraulic unit are continuously adjustable? Click on the correct answers, then confirm by clicking on OK. That's right. The inlet and switchover valves are continuously adjustable. The other valves can only switch between open and closed. Let's remind ourselves of the different factors which typically occur during unstable cornering. Firstly, there are the extreme levels of slip at the wheels. These slip levels can be calculated from the peripheral speeds of the wheels, with the aid of the wheel speed sensors. Lateral acceleration, which is monitored by the lateral acceleration sensor, must also be high. Unstable driving situations are also characterized by large side slip angles. That is the angle between the vehicle's longitudinal axis and the direction in which the vehicle is actually moving. The side slip angle is calculated using the signals from the steering angle sensor and the angular velocity sensor. By monitoring for these conditions, the electronic stability program is able to detect when the vehicle has entered an unstable driving situation. The electronic stability program then takes control by applying the brakes at individual wheels in such a way as to stabilize the vehicle. Take a look at this example of a vehicle accelerating sharply while cornering, which causes a tendency to oversteer. Click on the vehicle to see what happens in this situation. If excessive slip occurs at the rear wheels while cornering at speed, it will not be possible to build up sufficient cornering force at the rear axle, with the result that the vehicle's tail slips out sideways. The electronic stability program can prevent the tail from sliding out by applying the brakes in the right way. Do you know which wheel the brake should be applied at here? Click on the corresponding wheel. To counter vehicle oversteer, the electronic stability program brakes the front wheel on the outside of the curve. As well as corrective braking, the electronic stability program can also reduce engine torque and instructs the transmission control unit not to change gear. You are now familiar with what happens during regular braking, as well as with the conditions that trigger corrective interventions to stabilize the vehicle. What happens when the vehicle's brakes need to be applied sharply while cornering, but there is also a risk of handling becoming unstable? In this situation, the adaptive brake system uses the same sensor data as the electronic stability program. This data is supplied by the angular velocity, lateral acceleration and longitudinal acceleration sensor unit. The familiar lateral acceleration and angular velocity sensors are housed together in a single unit, along with an additional sensor, a longitudinal acceleration sensor. This longitudinal acceleration sensor monitors vehicle inclination and is only required for the auxiliary hill start assist function. Unlike the electronic stability program, the adaptive brake control unit calculates the optimum brake pressure for each individual wheel even in non-critical situations. This means that when the vehicle is braked in a curve, the brake pressure is higher at the wheels on the outside of the curve than at the wheels on the inside. This is possible because the adaptive brake hydraulic unit inlet valves are able to vary the brake pressure continuously, and thanks to the pressure sensors which monitor the brake pressure at each wheel. The fact that the adaptive brake system is able to adjust the brake pressure to the optimum level at all times means that the braking force at each wheel can be modulated to match each wheel's contact force. This way, the maximum braking power which is possible to transfer to the wheels can be applied when braking in curves too. At the same time, the system preemptively counteracts unstable handling situations instead of waiting until a response threshold has been exceeded, as the electronic stability program does. The electronic stability program continues to come to the driver's aid in critical situations. Which components of the adaptive brake system allow braking power to be maximized when the brakes are applied in a curve? Click on the components in question, then confirm by clicking on OK. Well done! The brake pressure at each wheel is adjusted continuously by means of inlet valves and measured by brake pressure sensors to ensure maximum braking power in curves. Under what conditions do the electronic stability program and the adaptive brake system take control? Click on the correct answers, then confirm by clicking on OK. Excellent. Whereas adaptive brake only takes action during vehicle braking, the electronic stability program is active all the time. On the other hand, the electronic stability program only intervenes in critical situations, while adaptive brake modulates vehicle braking continuously. In this way, the two systems complement one another. What corrective interventions can the electronic stability program and adaptive brake system perform? Click on the correct answers, then confirm by clicking on OK. Well done. Apart from the brakes, the electronic stability program can also make corrective adjustments to the engine and automatic transmission. Adaptive brake, on the other hand, is purely a braking system. ESP has been extended for the adaptive brake system to include a trailer stabilization function known as Trailer Stability Assist, or TSA for short. This driving assist system is capable of suppressing any snaking motion in car-trailer outfits by means of corrective braking and is active above a speed of around 65 km per hour. Click on the vehicle to hitch up the trailer. The Trailer Recognition Control Unit detects when the trailer coupling is being used. It is also responsible for controlling the trailer lights and monitoring the ball neck's locking mechanism. The Trailer Recognition Control Unit relays the information to the other control units, including the Adaptive Brake Control Unit. The Adaptive Brake Control Unit now assumes that the vehicle is towing a trailer and takes this into account when calculating any corrective ESP interventions to stabilize the vehicle. Trailer Stability Assist makes use of the Trailer Recognition and Adaptive Brake Control Units. Which of these two control units is responsible for detecting when the handling of a vehicle towing a trailer has become unstable? Click on what you believe to be the correct answer. The Adaptive Brake Control Unit's ESP function detects an unstable driving situation based on the input readings from the familiar sensors, in particular the lateral acceleration and angular velocity sensors. The Trailer Recognition Control Unit merely detects the presence of a trailer. Watch now to see how Trailer Stability Assist counters an unstable driving situation. Let's assume you are towing a trailer and have to take evasive action by abruptly changing lane at high speed. The trailer's momentum produces an extra moment of inertia at the trailer coupling, which can destabilize the outfit. ESP detects an unstable driving situation. Which wheel should be braked to generate the counter moment needed to stabilize the vehicle? Click on the wheel in question. In this case, ESP applies the brake at the front left wheel to build up a counter moment to that applied at the trailer coupling by the trailer. If necessary, engine power can also be reduced, and each of the vehicle's wheels can be braked individually. This has the effect of triggering the trailer's own overrunning brake, which then helps to slow down the outfit. Together, these measures bring the vehicle and trailer back under control. Since the vehicle's road speed drops as a result of these measures, the brake lights come on to warn traffic behind. Trailer stabilization is not just effective in critical handling situations. It can also come to the driver's aid when cruising along a straight road. Take a look at this example to see what happens when driving in a crosswind. Click on the vehicle trailer outfit to start. The system also detects any snaking caused by crosswinds. The trailer stabilization function is able to suppress the snaking motion more promptly than any driver could by applying counter moments alternately. The adaptive brake system includes a supplementary feature which enhances the braking effect when driving in wet conditions. This function is known as the brake drying function. It is triggered by the adaptive brake control unit as soon as the following conditions occur. The rain sensor detects that the windscreen is wet. The message "Windscreen Wiper Program Active" is relayed by the front SAM control unit, and the vehicle must be moving. Watch now to see how the brake drying function works. What happens when the brake drying function is activated? Brake drying is carried out by applying a brake pressure of less than 1 bar to the front wheels only for a couple of seconds. The brake pads are brought into contact with the brake discs, without the driver even noticing, at intervals which depend on the vehicle's speed. This disperses the film of water which accumulates between the brake pads and the brake discs as a result of spray from the road. The advantage of brake drying is that it makes the braking system more effective. Removing the film of water between the brake pad and brake disc at regular intervals means that the required braking power will subsequently be available that little bit sooner, because the two friction surfaces are already dry. In this way, brake drying helps to shorten the vehicle's stopping distance. The stopping distance can be broken down into the following components: the distance covered during the driver's reaction time, the distance covered during the braking system response time, and the actual braking distance covered while the vehicle is being slowed down. Which component of the stopping distance is shortened as a result of brake drying? Click on the correct answer from those shown. Brake drying cannot shorten the driver's reaction time nor the actual braking distance. However, it does shorten the braking system's response time and, as a result, the overall stopping distance. Adaptive brake also features a priming function. This function is active at all times and is triggered whenever the driver suddenly removes his foot from the accelerator pedal while the vehicle is moving. The accelerator pedal position sensor transmits a signal indicating the position of the pedal to the engine control unit, which in turn relays the information to the adaptive brake control unit. What does the control unit judge to be coming off the pedal suddenly? It determines a trigger threshold for each driver that takes individual driving styles into account. The next page gives you a closer look at how the priming function works. Click on the accelerator pedal to initiate the priming function. The high-pressure return flow pump is used to prime the hydraulics of all the wheel brakes with a pressure of up to 2 bar. What advantages does priming have? Priming closes the gap between the brake pads and brake discs. If the driver then presses the brake pedal, the fact that the brake pads are already in contact with the discs will enable a more prompt braking response, thereby shortening the vehicle's stopping distance. If the driver does not depress the brake pedal, brake priming will cease after a short time. That is, the brake pressure will drop again and the brake pads will move back into the rest position. The adaptive brake system's air gap function is activated by high-speed cornering. The various sensor readings, such as the angular velocity, the lateral acceleration, the rotational wheel speeds, and last but not least the steering angle, are used by the adaptive brake control unit to compute the current driving situation and detect cornering at high speed. The next page gives you a closer look at how the function works. If the threshold that signifies high-speed cornering is reached, a low level of brake pressure is built up at each wheel in the same way as for the brake drying and priming functions. This brings the brake pads into contact with the brake discs. Should one of the dynamic handling control systems subsequently be required to take action, the shortened brake pad travel will shorten the system's response time. Once the high-speed cornering maneuver is over, the brake pressure will drop again, and the brake pads will move back into the rest position. The brake drying, priming and air gap functions all involve the brake pads being brought into contact with the brake discs in certain situations. What conditions trigger each of the respective functions? Place only the relevant conditions next to each function, then confirm by clicking on OK. Well done, you have matched up all of the conditions correctly. Conventional brake lights are designed to indicate that the brakes have been applied and the vehicle is slowing down. However, it is difficult for drivers following behind to see whether the vehicle is merely being braked gently for a speed adjustment or whether it is being braked sharply in an emergency. The driver in the vehicle behind must gauge the situation based on the response of the vehicle in front and the current traffic situation. In other words, there is a delay before the driver recognizes a potential emergency braking situation. The adaptive brake lights are an additional function of adaptive brake. The adaptive brake lights are deployed when the rate of deceleration during braking exceeds 7.5 meters per second squared. They will only come on if the road speed prior to braking was more than 50 kilometers per hour. If the brakes are applied in an emergency in this way, the LEDs in the brake lights flash at a highly prominent frequency of 5.5 Hz in order to warn following traffic of the high rate of deceleration. This shortens the reaction time of drivers behind significantly, thus reducing the risk of them rear-ending the vehicle in front. If vehicles are braked to a stop with the adaptive brake lights activated, the brake lights stay lit continuously. The hazard warning lights are also activated when the vehicle comes to a standstill if it was travelling at over 70 kilometers per hour prior to braking. If the vehicle then pulls away, the hazard warning lights go out again as soon as its speed exceeds 10 kilometers per hour again. Which sensor do you think provides the necessary information on the rate of deceleration? Click on each of the alternatives in turn to find out the correct answer. This seems a likely answer, but the longitudinal acceleration sensor in the angular velocity, lateral acceleration and longitudinal acceleration sensor unit is only used to monitor vehicle inclination for the hill start assist function. A high brake pressure does indicate a high rate of deceleration, but there are exceptions. for example when the ABS system is taking corrective action. Consequently, the brake pressure sensor cannot provide a conclusive signal. That's right. The rate of vehicle deceleration is calculated from the reduction in wheel speeds. You have now reached the test section of this CBT program and can select test exercises from this page. Alternatively, you can simply click on Next to proceed to the next exercise that has not yet been completed.